So review for sequences. We're going to look at both arithmetic sequences and geometric sequences. Arithmetic sequences are sequences where you add the same number each time. And if you're looking from left to right and you can't tell what you're adding, then you're going to subtract. Take the second term, subtract the first. Negative 7 minus 1 is negative 8. Then take the third term, negative 15, subtract the second term. Negative 15 minus a negative 7 is the same as negative 15 plus 7, that's negative 8. And then do negative 23 minus a negative 15. That's the same as negative 23 plus 15, which is negative 8. If you get the same thing each time, we'll say yes, it's an arithmetic sequence, and the common difference is negative 8. Same idea on the second one. If you can look at it from left to right and tell, then you can go ahead and answer it, but if not, do subtraction. Negative 1 minus a negative 2 is positive 1. 2 minus a negative 1 is 2 plus 1, that's 3. Since they're not matching up, we can go ahead and stop and say, no, it's not an arithmetic sequence. It does not have a common difference. Number 3, same idea, 1.8, second term, subtract the first, you get 1.2. Do the third term, subtract the second, you get 1.2. Do the fourth term, subtract the third, we get 1.2. So we say, yes, it's an arithmetic sequence. The common difference is 1.2. This one, find the next three terms of the arithmetic sequence. So you already know it's an arithmetic sequence, so you can do the subtraction one time to figure out the common difference. 29 minus 35 is negative 6. So our common difference is negative 6. We're going to add negative 6 3 times. So 17 plus negative 6 would be 11. 11 plus negative 6 is 5. 5 plus negative 6 is negative 1. Then we already know it's an arithmetic sequence, so you can do the subtraction one time to figure out the common difference. Negative 15 minus negative 6, negative 15 plus 6, which is negative 9. So then we can do negative 33 plus negative 9 and get negative 42. Then do negative 42 plus negative 9 to get negative 51. And then do negative 51 plus negative 9 to get negative 60. So those are the next three terms of this sequence. Number 6, take the second term, subtract the first. We get positive 7. And we'll just add 7 3 times. So 4 plus 7 gives us 11 for our next term. 11 plus 7 gives us 18. (18 plus 7 gives us 25. So our next three terms are 11, 18, 25. All right, a sub 1 is the first term. In this sequence, it's negative 3. Common difference, do 2 minus a negative 3. We get 5. 7 minus 2 is 5. 12 minus 7 is 5, so common difference here is 5. Now to write the equation for the sequence. Substitute in place of a sub 1, put -3. Place of your d, the common difference, put 5. To simplify that, we'll distribute. Five times n is 5n, 5 times -1 is -5. Now we want to simplify this right side, so we're going to switch the order here. Commutative property of addition allows us to do that. Now we're going to combine those constants with like terms. -3 minus 5 is -8. Now we're going to use that equation to find the 20th term. Since we're looking for the 20th term, we'll replace n with 20. So we have a sub 20, or the 20th term, is equal to 5 times 20 minus 8. 5 times 20 is 100. 100 minus 8, 92. So our 20th term on the sequence, 92. Here we want to find the 30th term. The equation's already given to us, so we'll replace n with 30. Order of operations tells us to multiply before we subtract. 4 times 30 gives us 120. 120 minus 7 gives us 113. 30th term of the sequence is 113. Try and decide whether it's arithmetic, meaning you're adding the same number each time, geometric, or neither. So if we check arithmetic first, -15 minus 5, we'll get -20. 45 minus a -15, we would get 60. So it's not arithmetic. Now let's check geometric. For geometric, we're going to take the second divided by the first. And in this case, we get -3. Take the third divided by the second. And then if we take the fourth, -135 divided by the third, again we get -3, so we'd say it's geometric, and if we were asked to list our common ratio, we'd say that that is -3. Again, let's check arithmetic. We'll do -1 minus 8, that's -9. -10 minus a -1, we get -9. -19 minus -10, we get -9. So we'd say, yes, it is an arithmetic sequence. The common difference, if we're asked for it, is -9. One minus 1 is 0. 2 minus 1 is 1, so it's not arithmetic. 1 divided by 1 is 1. 2 divided by 1 is 2, so this is not geometric. This one happens to be neither. Now, just because it's neither doesn't mean there's not a pattern. The pattern here is you add the previous terms. The previous two terms, I should say. So 1 plus 1 gives us 2. 2 plus the 1 gives us 3. And then 3 plus 2 gives us the 5. And then 3 plus 5 gives us the 8, and so on. It's called the Fibonacci sequence, but it does not fit arithmetic or geometric, so we say neither. Find the next three terms of the geometric sequence. So figure out what your common ratio is by putting the second divided by the first. We get -4. Alright, now this is a geometric sequence. Sorry, I had the wrong sequence up there. 4 divided by -1 is -4. So that's our common ratio. Now to continue this sequence, we'll take the 64, multiply it by -4, and we get -256. So that's the next term in the sequence. Now let's do -256 times -4. It'll be positive. You get 1024, then do 1024 times -4. Get -4096. So these are the next three terms of the sequence. For 16, if you do 1 divided by 1/3, you get 3. Be easier to see it with 3 divided by 1. It's 3. So our common ratio is 3. So the next term would be 9 times 3, or 27. And then 27 times 3 gives us 81. And 81 times 3 gives us 243. So the next three terms, 27, 81, 243. One of the things that will clue you into the fact that the common ratio is negative on 15 is the fact that they're alternating signs. 17 and 18, you're trying to decide if it's a geometric sequence, and if it is, we'll write the common ratio. So do 1 divided by 1/7, you get 7. Do 7 divided by 1, you get 7. Do 49 divided by 7, you get 7. So that means, yes, this is a geometric sequence. Common ratio is 7. Same directions. Do 12 divided by 36. It's 1/3. Do 4 divided by 12. Simplifies to 1/3. And then 4/3 divided by 4. If you're not using a calculator, the way that you'd figure that out is 4/3 divided by 4/1. Divide fractions, multiply by the reciprocal. And so we get 4/12, or 1/3. So every time here we get 1/3, so we'd say yes, the common ratio is 1/3. This one, we're missing a term. Now to go from 10 to 1, we could either add -9 or multiply by 1/10. So let's see what adding -9 would do. 1 plus -9 gives us -8. Now if that's the missing term, then -8 plus -9 should give us -17, and it does. So the missing term here is -8. Again, if that didn't work, we'd go down the geometric route. Alright, number 20, we've got to write an equation for the geometric sequence. A sub 1, that's the first term. So our first term here is 5. Common ratio, we'll do the second divided by the first, and we get 3. Now, we're told it's a geometric sequence, so we don't have to check them for all the different terms. First term's 5, common ratio is 3, and minus 1. The n will stay in your equation. That's the equation for the geometric sequence. It would allow you to find any term in the sequence without finding previous terms. Like you could find the 100th term just by replacing n with 100. Hope you've enjoyed this video on sequences review.